Software for synthesis and visualization of EMR data from the virus COVID-19 registry. An early version of this pandemic rapid research software platform was developed at the request of the Obama White House in response to the Zaire Ebola virus epidemic in 2014. Since that time, development of the software has been continued by Lintech Medical Technologies to support rapid research during future pandemics. The investigators of the COVID-19 registry have no conflicts of interest to report, and further details are provided at the end of this video. To provide effective care, hospitalists must track a large number of test results and treatments. Challenging even in normal times, providing effective care is uniquely difficult during a novel pandemic when the adverse relational time patterns are unknown. Relational time patterns are relational or combined vectors of lab, vitals, hemodynamic, and ventilation variables, intake, output, and treatment. Patients display a complex underlying time series matrix of relational time patterns in relation to different treatments. To identify more effective forms of care, the virus COVID-19 registry has identified novel software that can provide a unified model of adverse time patterns in relation to treatment of COVID-19. It can provide patient-centered data visualization to facilitate hypothesis generation, can expedite further research through cohort building and trial development, and it provides embedded regression and machine learning capabilities. Basic search allows investigators to explore the cases for hypothesis generation. Detailed filters and menus allow investigators to specify populations of interest. Cohorts may be further selected by choosing time patterns of lab, vitals, or treatments as filters. As one example, you can search for COVID-19 cases that exhibit rising anion gap. Cohort with time dependency can be built by selecting time patterns of lab, vent data, or vitals with timing of treatment in order to study efficacy or adverse events in relation to treatment or procedure type and time. For example, you can search for COVID-19 cases where absolute lymphocyte count rises subsequent to hydroxychloroquine. Here's a brief example from a recent epidemic, a case of Zaire Ebola virus infection. Patient-centered data visualizations facilitate pattern recognition and hypothesis generation. This visualization is one example of many. On the left, perturbations and recoveries are detected as rise and fall vectors. Here, a fall in platelets is detected. The features of the fall, such as magnitude, percent change, slope, nadir, onset time, and end time, are stored for machine learning. On the right, the vectors are aggregated to offer a global view of the patient's progress over time, as well as more specific views of relational perturbations of each physiological system over time. Here's an example of a visualization of the relationship of two treatments over time, fluid and oxygen delivery. Note that the software can detect vectors of treatment and ventilation-associated care, including features such as slope, magnitude of change, and peak value. As an optional feature, the software provides logistic regression and machine learning models to identify predictors of rapid deterioration. For example, logistic regression and machine learning models can find relationships between treatments, perturbations in relational time patterns, and outcomes, such as rapid clinical deterioration. In conclusion, the virus COVID-19 registry will be using this software to learn more about the progression and relational time patterns of COVID-19, to develop hypotheses regarding ways to improve management and treatment, to build cohorts for further research, and to support application of regression and machine learning to predict deterioration.